Hey all, welcome to Komali Mam online classes. Today is solid state Intext and exercise questions day 2. In this session, Intext questions I'm going to cover from 1.14 to 1.28. Let's begin the question number 1. 1.14. In last session, part 1, I discussed, day 1, I discussed 1.13 to 1.1 to 1.13 I covered. Now I am going to teach you from 1.14. What is the two-dimensional coordination number of a molecule in a square closed packed structure? Actually, in a square, how the square closed packing will be in a two-dimension, I'll draw and show you. See the structure here. This is one sphere, one sphere, one sphere, one sphere. Exactly on the top of the sphere, same line you draw. Like this, exactly top, same line, like this, exactly down like this, one layer. So now take any one atom. This atom is surrounded by 4 other atom students. Just to connect it, if you listen each and every question like this, your preparation from NCERT becomes very easy. You can be able to solve any question from NCERT. Then here, this is in touch with 4 other atoms. So coordination number will be 4 here. What is the coordination number? Can you tell me? Coordination number is 4. So in square closed packing, coordination number is how much? 4. A compound, next 1.15. A compound forms hexagonal closed packed structure HCP. And they were asking what is the total number of voids in 0.5 mole of it. How many tetrahedral voids are present? See, 1 mole of any substance contains 6.023 into 10 power of 23 atoms. So 0.5 mole is nothing but half a mole. Half a mole contains how many atoms? Half of 6.023, how much? Around half of that value will be, you remove this in order to make it very short. So 3 into 10 power of 23 atoms, because half value are taking. 1 mole is 5 rupees, then half mole how much? Half of 5 is 2.5, like that. These many atoms are present. What is the trick here? Trick is, normally, how many atoms are there? Tetrahedral voids will be double the number of atoms. Octahedral voids will be same number of atoms. So, here tetrahedral voids will be double the number of atoms, that is 2 into 3 into 10 power of 23 atoms. Then octahedral voids will be same number of atoms, that is 3 into 10 power of 23. These many voids. Now add both 6 into 10 power of 23 plus 3 into 10 power of 23. How much, students? 9 into 10 power of 23 is your answer. Got it? So in such a way, here you can skip this 0.23. Then it will be, you feel comfortable. See the next question. A compound is formed by 2 elements. What are those 2 elements? M and N are the 2 elements. The element N forms CCP. What that element N forms? It forms CCP, and M occupies 1/3 of the tetrahedral voids. What is the formula of the compound? This is the formula. Now what you have to do is, N forms CCP, means the number of atoms will be 4, and M forms tetrahedral voids 1/3. Actually, number of atoms are 4. Then tetrahedral voids will be double the number of atoms. So 8, in that only 1/3 are present. So it will be 8/3. That's it. M is 8/3. N is 4. Then it will be just do a cross multiplication. Then it will be 4 3s are 12. Then fourth table you take simplest ratio. 4 2s are and 4 3s are 12, right? So M2 N3 will be the formula. What is the formula? M2 N3 is the formula. Is it clear? See the next question. Which of the following lattices has highest packing efficiency? Simple cubic BCC and FCC. Simple cubic packing efficiency is 52.4. BCC is 68%. HCP is 74%. So HCP is having highest. Repeat one more time. Simple cubic is how much, students? 52.4%. BCC is 68%. HCP is 74%. Next question. An element with molar mass is 2.7 into 10 power of minus 2 kg. M value is given. And edge length it is having 405 picometers. And density is 2.7 into 10 power of 3. What is the nature of cubic unit cell, they were asking. Then how to solve this numerical? Let us see. Rho is equal to Zm by A cube Na is the formula. Repeat the formula. Rho is equal to Zm by A cube Na is the formula. What we have to find? We have to find Z. Then only we will come to know the nature of the substance. Then rho into A cube into Na divided by M. What is the rho value density? 2.7. This is actually 2.7 into 10 power of 3. kg meter cube they have given. Kg per meter cube. A value 405 picometer. 1 picometer is 10 power of minus 12 meter. 1 picometer 10 power of minus 12 meter. Why I am taking in a meters? Because in a question, density is given in kg per meter cube. That's why I am taking kg per meter cube. Into Avogadro number is 6.023 into 10 power of 23. Molar mass is given 2.7 into 10 power of minus 2. Here 2.7 cancel. Here 10 power of 2 comes up. It will be 10 power 5. And here 10 power of 23 is there. 10 power of 23 and 6.023. Remove this for easy calculation. 6 and 4.05. 405. I'll write it as 4.05 into 10 power of minus 10 whole cube. See this one. If you change in this format, it will become easy for you instead of doing whole cube of that entire value. Now I'm going to do 4 cube. Like I'm neglecting this term and I'm doing. And then 4 cube, how much? 4 4s are 16. 16 4s are 64. So 64 into 6. And this one will be 10 power of minus 30. This 2, if you add 10 power of 28, it will be 6 4s are 24. 2 6 6 are 36. 38 into 10 power of minus 2. Then it will be 3.84, is the number of atoms, Z value, which is approximately equal to 4, which means that it is having FCC structure. So FCC, atoms are present at corners and atoms are present at face centers. Okay, now this is your solution. If you want, take it out, check it out. But what the way I have done, if you do it in such a way, it will be easy for you. See the next one. What type of defect? Same thing. Applying in the substituting in the formula and solving. What type of defect can arise when a solid is heated? Actually, when a solid is heated, some particles go, some molecules goes out of the unit cell. Then vacant spaces are created. That's why this defect is called as vacancy defect. Which defect? Vacancy. Because on heating, some atoms, on heating, what is going on, students? Some atoms or ions leaves the lattice sites. When it leaves the lattice sites becomes vacant. Lattice sites becomes vacant. So when lattice sites becomes vacant, then the density of that unit cell decreases. What happens? Density of the unit cell decreases. Is it clear? See the next question. What types of stoichiometry defects are shown by ZnS and AgBr? See, ZnS shows Frenkel defect, whereas AgBr shows both Frenkel defect as well as a Schottky defect. This is a direct question from, and examples is mandatory. You all should remember the examples. The AgBr most important. It shows both Frenkel defect as well as a Schottky defect, whereas ZnS shows only Frenkel defect. Is it clear? See the next question, students. 1.21. Explain how many vacancies or how vacancies are introduced in an, how vacancies, not how many, how vacancies are introduced in an ionic solid when a cation of higher valency is added to the added as an impurity. See, when you add an impurity, for example, let us take Na plus Cl minus, NaCl solid you take, NaCl, Na plus Cl minus, Na plus Cl minus, again Cl minus Na plus, again Cl minus Na plus. When you are taking like this, you are removing one sodium. In that place, another higher impurity like strontium. You want to add a strontium. So one Sr2 plus will replace two Na pluses. Are you understanding why it will replace two Na plus? Because it is having +2 charge. So to maintain that electrical neutrality, one Na plus, one Sr plus 2 will replace two Na pluses. In that one place, it will come and occupy Sr2 plus. So in such a way, these vacancies will be created. See here. If you take NaCl example, we are doping with SrCl2. Then when SrCl2 is added, two Na pluses will be removed and Sr2 plus, this is Sr2 plus will be occupied. Sr2 plus will be occupied and one position will remain vacant. Here one position out of two sodiums it will replace and one place it will occupy. So cations of higher valency, when we add as an impurity, two or more cations of lower valency will be replaced with a cation of higher valency. It is because to maintain that electrical neutrality, that is the reason cationic vacancies are created. What vacancies are created? Can you tell me? Cationic vacancies are created. See the next question. Ionic solids which have anionic vacancies due to metal excess defect develop color. Explain with the help of a suitable example. What is this? Ionic solids which have anionic vacancies due to metal excess defect develop the color. Actually, why it develops a color? We have seen the example of ZnO. In ZnO example, or NaCl heating in the presence of sodium vapor, what happens? When we take NaCl, Na plus Cl minus, Na plus Cl minus. So what I'm going to do, students, here I'm taking Na plus and Cl minus, means NaCl solid I'm taking here. Then I am heating it in the presence of sodium vapors. Here sodium vapors. When I'm heating it in the presence of sodium vapors, this Cl leave its site and it goes out. to combine with Na. That Na, it lose one electron and it will be ready as Na plus, because the Cl minus is coming, both will form NaCl. That is the reason this Na converts into Na plus. Whenever this Na converts into Na plus, that electron is there, right? This electron comes and occupy this Cl position, because Cl is going out, that place electron is occupying. From where that electron is coming? Because Na is losing that electron. Now this is called as an F center. This F center absorbs energy and it goes to the excited state. Excited state is not stable. Again, it comes back to the ground state. When it is coming back to the ground state, it emits the radiations, whatever it is absorbed. That radiations will be emitted, observed as a color. Got the clarity? So here, it is observed as a color. See, let us take an example of NaCl. When NaCl is heated in the presence of sodium vapors, what is happening when it is heated in the presence of sodium vapors? Cl minus ions leaves the site. It leaves the site and it tries to combine with the sodium. So sodium loses one electron, converts into Na plus. Now this Na plus and Cl minus both combines and form NaCl. Whatever that site Cl minus left, right, that is called as a F center and it is occupied by the electrons. Now this electron absorbs the visible radiations and it goes to the excited state. It is not stable. Again, it comes back to the ground state. When it is coming back to the ground state, it emits the color. That color will be yellow color. So NaCl shows yellow color. NaCl shows yellow. LiCl, NCERT examples. LiCl shows pink color. KCl shows violet or lilac color. What is the color? KCl shows violet or lilac color. Is it clear? See the next question, students. Next question. A group 14 element is to be converted into N-type semiconductor by doping it with a suitable impurity. To which group should this impurity belongs? What is that? Group 14 element is to be converted into N-type semiconductor. See, N-type means what are responsible electrons are. N-type semiconductor means one electron should be extra. One electron should be extra means this is 14th group. We should add 15th group element. Then only it becomes an N-type semiconductor. So impurity of 15th group should be added. Impurity of 15th group should be added. Then only we will get N-type semiconductor. To get a P-type semiconductor, which group should be added? 13th group should be added. Next question. What type of substances would make better permanent magnets? Ferromagnetic or ferrimagnetic? Justify your answer. Ferromagnetic substances are permanent magnetic substances. Why? Because in ferromagnetic substances, small atoms are grouped together. What will happen, students? Small atoms group together. And the small atoms group together, and see, every metal atom have electrons. These electrons acts like a magnet. Okay, these small atoms comes together and it forms a domain. Actually, in the absence of external magnetic field, all the domains are in different directions. But once we keep the magnetic field, all the domains will comes to the same direction. So I want to tell you that every metal atom has some unpaired electrons. What is that? Every metal atom has some unpaired electrons. So this is one metal. All these are the metals. When we put some external magnetic field, when we keep some external magnetic field, then all these electrons and their, magnetic fields, every electron in a metal atom acts as a magnet. So all are in all different directions in absence of external magnetic field. But in the presence of external magnetic field, all comes to one certain direction. Got it? So all together we call it as one domain. One domain. All domains are in one direction. Then we call it as a ferromagnetic substance, and it is a permanent magnet. If you remove the external magnetic field also, it will act as a magnet. See here, ferromagnetic substances are ferromagnetic substances make better permanent magnets. When it is placed in a magnetic field, their domains gets oriented in the direction of magnetic field, and a strong magnetic field is produced. And if you remove the external magnetic field also, their domains remains the same. And hence, ferromagnetic substances becomes a permanent magnet. They act as a permanent magnet. So total how many questions? 1.28, I don't know, 1.24. So these are the in-text questions. In a next session, I will teach you exercise questions from solid state chapter. I hope you understand this session. See you in the next session. Take care. Have a nice day. Bye, students.